So, welcome to our worked example looking at how to utilize the formula equation for calculating elastic potential energy. So, as you can see, elastic potential energy equals half times spring constant times extension of an elastic object, such as a spring, squared. Now, our units are important. Energy is measured in joules, spring constant, as is used before, is measured in Newton meters, and extension, as in previous equations that we've used, is measured in meters as well. So remember, any units that you use in trying to calculate any of these terms have to be converted back into these before getting a correct answer. So if we have a look at an example and see how we can apply this. So our example says calculate the amount of energy stored in the following spring with a spring constant of 12.6 Newton meters and an extension of 3.6 meters. So we know that elastic potential energy equals 0.5 times, use K for our spring constant, times extension squared. So to get this, 0.5 still is 0.5, don't need to go over that. 12.6 Newton meters is absolutely fine because our unit is Newton meters, so we don't have to convert it. But our extension is 3.6 centimeters. Now we need that measurement figure to be in meters. So we need to convert it before we put it into our equation. Now to do that, we have to divide our number by 100. So 3.6 divided by 100 should bring us out with our unit measure in meters. So 3.6 divided by 100 gives us 0.036. That's 0.036 meters, and that is squared. So we then substitute in our values, we then simply cancel it down. So we have to do our 0.036 squared to begin with. So 0.036 times 0.036 gives us 0.5 times 12.6 times 0.001296. So we then just simply multiply each of our numbers together. Gives us 0.00817. So 0.5 times 12.6 times 0.001296 bring us out with this, which, as it is energy, our answer needs to be in joules. So that's how we go about using the elastic potential energy equation of 0.5 times spring constant times extension squared. Now, don't forget, you may need to use rearrangements of this equation. So, to rearrange it, spring constant, to calculate spring constant, becomes elastic energy divided by 0.5 times extension squared. Whereas if you want to work out the extension of an elastic object, because we have to get rid of our squared, our other side has to be square root of elastic energy divided by 0.05 times spring constant. Okay, so these are two rearrangements of the equation. So, a worked example of how to use elastic potential energy equation utilizing spring constant and extension of elastic object.